Chapter Determinants, Exercise 4.6. Solve system of linear equations using matrix method. Question number 11. 2x plus y plus z is equals to 1. X minus 2y minus z is equals to 3 by 2. 3y minus 5z is equals to 9. You have to solve these system of linear equations by using matrix method. So let us see the solution, how to solve the given problem. So first we write the system of linear equations in the matrix form, that is Ax is equals to B. So where A is the coefficient matrix, so A is equals to, so if you write the coefficients of x, y and z, so if you consider first equation, coefficient of x is 1, coefficient of y is 1, then coefficient of z is 1. Similarly, in the second equations, if you write the coefficients of x, y and z, that is 1 minus 2 minus 1. In the third equation, there is no x variable, so coefficient of x is 0, coefficient of y is 3 and coefficient of z is minus 5. And the matrix X is the column matrix, so that is equals to, we write the variables, here the variables used are x, y and z. So again matrix B is the constants in the RHS of the equations. Their constants are 1, 3 by 2, 9. That is 1, 3 by 2, 9. Now let us check whether the matrix A, that is coefficient matrix, is singular or non-singular. So consider the determinant of A. So determinant of A is equals to determinant of 2, 1, 1. 1 minus 2 minus 1. 0, 3 minus 5. So this is the determinant of A. So if you expand the determinant of A along the first row, so if you expand along first row, that is 2 into second order determinant obtained by deleting the first row and first column. If you delete the first row as well as first column, so we will get minus 2, minus 1, 3, minus 5. Next element, minus 1 into second order determinant. Here this 1 lies in first row, second column. So delete the elements in first row as well as second column. So we get the second order determinant, that is 1, 0, minus 1, minus 5. Plus 1 into, again this 1 lies in first row, third column. So if you delete the elements in first row as well as third column, so the second order determinant obtained is 1 minus 2, 0, 3. So that is equals to, so now expand the values, that is 2 into, so if you expand this determinant, minus 2 into minus 5, that is minus 2 into minus 5 becomes 10, minus 1 into 3, that is minus 3, minus 1 into 1 into minus 5, that is minus 5, minus 1 into 0, that is 0, plus 1 into 1 into 3 is 3, minus 2 into 0, that is 0. So that is equals to 10 minus of minus 3, that is 10 plus 3 becomes 13, 13 into 2 becomes 26. Here minus 5 into minus 1, that is minus plus 5, plus 1 into 3 becomes 3. So that is equals to 26 plus 5, 31, 31 plus 3 becomes 34. So determinant of A is equals to 34, which is not equals to 0. So determinant of A is not equals to 0. So what we can say, A is non-singular So since A is non-singular, A inverse will exist. We know that A inverse is equals to 1 by determinant of A into adjoint of A. So already we obtained the value of determinant of A, that is determinant of A is 34. Now let us compute the value of adjoint of A. So we know that adjoint of A is the transpose of the cofactor matrix. So now let us find the minors and cofactors. After that we compute the value of adjoint of A. Then we substitute adjoint of A in the equation to compute the value of A inverse. Now let us compute the cofactors. So that is A11, A12, so on till A33. So first element here, A11 means first element in the first row, that is 2. Its minor is denoted by M11. To calculate the minor M11, so we have to exclude the elements in the rows and the columns in which A11 lies. Here A11, so that lies in first row as well as first column. So this 2 lies in first row as well as first column. So we are excluding the elements in the first row as well as first column. Next, consider the determinant of the remaining elements. So that is determinant of minus 2, minus 1, 3, minus 5. So what we will get? Minus 2 into minus 5, that is 10, minus 1 into 3, that is minus 3. So 10 plus 3 becomes 13. So the value of M11 is 13. Now cofactor A11, here sum of the suffix, that is 1 plus 1, 2. When the sum of the suffix is even, minor and cofactor will be same. So what we can write, A11 value is also 13. Now A12 means second element in the first row, that is 1. Its minor is denoted by M12. Again what we have to do, A12 lies in first row and second column. So this 1 lies in the first row, second column. So exclude the elements in first row, second column. So consider the determinant of the remaining elements. So remaining elements are 1, 0, minus 1, minus 5. So if you expand the determinant, 1 into minus 5, that is minus 5, minus 1 into 0, that is 0. That is equals to minus 5. So the minor M12 becomes minus 5. And cofactor A12, here 1 plus 2 means 3, which is odd. So whenever the sum of the suffix is odd, cofactor will be negative of the minor. So negative of minus 5 becomes 5. Now A13 means third element in the first row, that is 1. Its minor is denoted by M13, that is equals to, again exclude the elements in the first row as well as third column, because this A13 lies in first row, third column. So if you exclude the elements in the first row as well as third column, now consider the determinant of remaining elements. So remaining elements, that is 1, minus 2, 0, 3. So that is equals to 1 into 3 becomes 3, minus 2 into 0, that is 0. 3 minus 0 becomes 3. So the value of M13 becomes 3. And its cofactor A13 is equals to, again sum of the suffix 1 plus 3 becomes 4, which is even. So cofactor and minor will be same. The value of A13 is same as M13. Similarly, if you compute the cofactor of other elements, so we are computing same procedure, A21, A22, A23, so on till A32. Now last element A33, that is minus 5. Its minor is obtained by, so here minus 5 lies in the third row as well as third column. So if you exclude the elements of the third row and third column, and if you take the determinants of remaining elements, that is 2, 1, 1, minus 2, that is equals to 2 into minus 2 becomes minus 4, minus 1 into 1 is 1, that is equals to minus 5. So the value of M33 is minus 5. Then cofactor 833. So 3 plus 3, 6, even number. So cofactor will be same as minor. So the value of 833 becomes minus 5. Now we know that adjoint of A is equals to transpose of the cofactor matrix. So in the earlier step we obtained the values of cofactors A11, A12, so on. So substituting here we will get this much. So since we have the transpose, means we have to interchange rows and columns. Transpose means interchanging rows and columns. So write first row as first column. So what we will get? First column as 13, 5, 3. Second row as second column 8 minus 10 minus 6. Third row as third column 1, 3 minus 5. So this is the value of adjoint of A. Now let us compute A inverse. A inverse is equals to 1 by determinant of A into adjoint of E. So determinant of A we obtained 34. So substitute here, we will get 1 by 34 into adjoint of A. Adjoint of A is equals to this much, that is 13, 8, 1, 5 minus 10, 3, 3 minus 6 minus 5. So this is the value of A inverse. Now we know that the solution of the system of linear equation is given by x is equals to A inverse into B. Here x is the column matrix, that is x, y, z is equals to A inverse. We obtain the value of A inverse, that is 1 by 34 into matrix 13, 8, 1, 5 minus 10, 3, 3 minus 6 minus 5 into B. B is the matrix again 1, 3 by 2, 9. So that is equals to 1 by 34 into, so if you multiply these two matrices, if you multiply the corresponding elements of first row with first column, that is 13 into 1 plus 8 into 3 by 2 plus 1 into 9. Again second row with first column, that is 5 into 1 plus minus 10 into 3 by 2 plus 3 into 9. Again third row with first column, 3 into 1 plus minus 6 into 3 by 2 plus minus 5 into 9. So that is equals to 1 by 34 into, simplifying, 13 into 1, 13 plus 2 4s are 8, 4 3s are 12 plus 9, here 5 minus 15 plus 27, 3 minus 9 minus 45. So that is equals to 1 by 34 into, here 25 plus 9, 34 minus 10 plus 27, that is 17, here minus 6 minus 45, that is minus 51. So if you multiply 1 by 34 to each element of this column matrix, we get 34 by 34 means 1, 17 by 34 means 1 by 2, minus 51 by 34 means minus 3 by 2. So this is the column matrix x, y, z is equals to, we got column matrix 1, 1 by 2 minus 3 by 2. So if you equate the corresponding elements of these two matrices, so we will get the value of x is equals to 1, y is equals to 1 by 2, and z is equals to minus 3 by 2. So this is the required solution of the given system of linear equations. So thank you.